Hello everyone, this is INE Foundation Lab 2, section 6.2, IPsec over DMVPN. Okay, before I complete this section, let me explain what is IPsec and how it works with DMVPN. And I will come back and configure this section. Okay, like DMVPN, IPsec uses multiple protocols, or it's a suite of protocols. One is IPsec. It uses encryption technology to provide data confidentiality, integrity, and authenticity between participating peers in a private network. The other technology that it uses is Internet Key Exchange, or IKE. It is important to understand that in Cisco, IKE is the same as, or is called, Internet Security Association and Key Management Protocol, or ISAC-MP. ISAC-MP is the same as IKE in Cisco. IKE provides security association management. And the third technology that IPsec uses is certificate management. Cisco supports X509 version 3 certificates for device authentication during IKE negotiation. These are IPsec technologies. The core technology that we have to understand and configure is this IKE. This is called IPsec protocol, or ISAC-MP. Okay, IPsec uses IKE protocol to negotiate and establish secure site-to-site or remote access VPN tunnels. As I said before, IKE is also called as ISAC-MP in Cisco. There are two versions of IKE. One is version 1 and the other one is version 2. Okay, IKE phases. There are two IKE phases. One is phase 1 and the other one is phase 2. Phase 1 is called ISAC-MP tunnel, and phase 2 is called IPsec tunnel. In phase 1, the two ISAC-MP peers establish a secure and authenticated tunnel which protects ISAC-MP negotiation messages. In other words, ISAC-MP protects the control plane VPN traffic between the two gateways. ISAC-MP protects control. ISAC-MP, in other words, phase 1 protects control plane VPN traffic. There are two modes. One is called main mode, or MM, or aggressive mode, or AM. Main mode and aggressive mode are two modes of ISAC-MP tunnel, or two modes of phase 1 tunnel. This is important to understand for troubleshooting. And the second phase is phase 2, or IPsec tunnel. It negotiates key materials and algorithm for the encryption essays of the data to be transferred over IPsec tunnel. In other words, it protects the data plane traffic that passes through VPN between two gateways. IPsec tunnel protects data plane traffic of IPsec. ISAC-MP protects control plane traffic. These are the differences. We have and IPsec tunnel. We have one mode. This phase is also called quick mode. Quick mode is for phase 2 IPsec tunnel. And main mode and aggressive mode is for ISAC-MP tunnel. Okay, now let's see how we can configure IPsec. As we already know, there are two phases. One is IPsec, IPsec tunnel, and IPsec tunnel. We have to configure these two phases. If not, this is it's a second policy. This is the same as phase one, and this IPsec profile is phase two. Okay. Okay, first we configure phase 1 or IPsec P tunnel. The configuration is so simple. For configure phase 1 or IPsec tunnel, we type crypto IPsec P policy and number. This is one number. What is it? Policy number. This is our policy number. Then under this command, we have to configure encryption, hash, authentication, group number. This is the Feldman group, and lifetime session. This is session key lifetime. We configure these parameters under this crypto IPsec policy command. This phase 1 policy is defined globally. If we have 5 different remote sites and configured 5 different IPsec policies, for one for each remote, it will send all 5 policies and use the first match that is accepted by the both sides. Let me there. Okay, if you have one hub and 3 remote sites, and for this site 1 and this is site 2 and this site 3, and if we configure 3 policies, it will send all 3 policies to each side. This is 1 2 3 for this one, 1 2 3 for this one, and 1 2 3 for this one. Use the first match that is accepted by both ends. If we have match, it will be accepted. Phase 1 policy is defined globally. This is to understand. Okay, first we configure crypto IPsec policy. This is phase 1 or IPsec tunnel configuration. Then we have to configure IPsec MP key. Okay, we can configure in 2 ways. One is by crypto IPsec MP key number, key name, and address, which is remote address, or we can use wildcard P patient keys. The 0000 and 0000. This is wildcard patient keys. We can configure in 2 ways. This is we can use remote IP address or wildcard patient keys. Crypto IPsec key name, address and 000. Okay, that is it. It was the first or second P configuration, this phase 1 configuration, we only have two commands. One is this crypto account policy and crypto account key and key name and address, remote address or wildcard P share keys or 0000. Okay, then we have to configure phase 2 or IPsec tunnel. For configure this phase, we use crypto IPsec transform set command, and then we specify the transform set name. Then we specify our algorithm, encryption method, hashing, and algorithm after this name. Then under this crypto IPsec transform set, we specify our IPsec mode. We can specify either transport or tunnel. What are the difference? Transport mode encrypts only data portion or payload of each packet and leave the packet header untouched. This is transport mode. It's only encrypts data portion of packet, but tunnel mode encrypts both payload and header. Tunnel mode is more secure than transport mode. This is the difference between transport and tunnel. This mode is under crypto IPsec transform set command. Okay, that's it. This is for phase 2 configuration. This command is for phase 2, and these two commands are for phase 1. Okay, we have multiple IPsec configuration modes. In all of these modes, this phase configuration are the same. There is no difference between them. In all of this IPsec configuration mode, we have to configure phase 1 and phase 2. Okay, let's see this IPsec mode configuration and what are the differences. Okay, we can configure IPsec in these modes. One is first IPsec IPsec VPN with crypto maps. This is without GIE tunnel. Then we can configure IPsec with GIE over IPsec with crypto maps. We have GIE tunnel here. Then we have GIE over IPsec with crypto profile, and we have IPsec with tunnel interfaces. We can configure IPsec with tunnel interface. In all of these modes, we first configure these phases by these commands. Then let's see what are the differences in each mode. Okay, in IPsec with crypto maps, for this is in IPsec for crypto map, we have to specify extended access list. This is to match our interesting traffic. If source IP address and destination to match which traffic we want to encrypt. First we have to configure IPsec. We have to configure extended access list. By this command, we configure IP access list extended and extended IP access list name. Then we permit our source and destination IP. This is our permit our interesting traffic. After configuring extended access list, we have to configure crypto map. Create crypto map simply by this command: crypto map name or number, and specify IPsec IPsec MP. Then we under this command we specify our remote P. This P is set P is the set P remote IP address is usually this IP address we specify for crypto ASICM keyname address. This crypto ASICM keyname address, and this one is set. Then we set our transform set. This is the transform set that we have already configured for IPsec Phase 2. This is this transform set name. Crypto IPsec transform set. Then we have to set this on the crypto map. Then we match our extended access list that we have created here. At the end, we upload our crypto map for our physical interface. If we don't have GRE tunnel, we have to upload it to physical interface. Crypto map name. This is the same name here. We come crypto map and crypto map name. And only one crypto map can be assigned to an interface. We can't conquer 2 or 3, only one. So this is important to understand. Another option we can compare is with dynamic crypto maps. This is so similar to crypto map. Let me explain this one. First, we create the extended access list to match our interesting traffic. This is IP access list extended around specify extended IP access list name. Then we permit our interesting traffic. Then we create our dynamic crypto map by this command: crypto dynamic map name and number. And we specify our set P. This is the same as here. Set P for this remote IP address. Set P set transfer set. We have configured for phase 2. The transfer set name. And match our extended access to or interesting traffic. After configuring this dynamic crypto map by this command, crypto dynamic map, then we have to create crypto map and assign it to our dynamic map. We create crypto map name, number, IPsec ASICM, and we specify dynamic command and assign our dynamic map to our crypto map. This name should be same as this name here. And upload to our upload dynamic map to our interface is the same as crypto map. And it is important to understand that we specify our crypto map, not dynamic map name. For uploading, we use our crypto map name, not dynamic map name. Okay, third one is crypto profile. IPsec with crypto profile. Okay, instead of creating crypto maps or dynamic map, we create IPsec profile. This is the command is here is this. Crypto IPsec profile and specify profile name. Then we set our transfer set, and this is transfer set name. This should be this one. Our transfer set name. And under our tunnel interface, this is the company used to use. This is usually with GRE tunnel. Under our tunnel interface, we type tunnel protection, IPsec profile, and profile name. That's it. We don't have to create interesting traffic. This is IPsec crypto profile. This is more simple than crypto profile. And the last option, we have IPsec with a tunnel interface. This is same as crypto profile. We create crypto IPsec profile name, and set TS name. And under our tunnel interface, we use tunnel protection IPsec profile name. The difference is this command. We have to type tunnel mode IPsec IPv4. This command under tunnel interface will make IPsec virtual tunnel interface. This command, tunnel mode IPsec IPv4. This is the difference between crypto profile and virtual tunnel interface. We have this command. Okay, so in this scenario, because we have DMVPN and IPsec, in some cases we have to use this feature, shared IPsec with tunnel protection feature. What is this feature? Okay, the sharing IPsec with tunnel protection feature is used to create a single IPsec. This is IPsec database for all the tunnel interfaces that use the same profile and tunnel source interface. So create a single IPsec profile for all tunnel interfaces that use same profile and same tunnel source interfaces. Here, let me expand here. This is here ensure that single IPsec profile is used on R7 for both tunnel. Okay, let's run this. Okay, here R1 is hub and 8 is spoke, 1 is a spoke. We have 2 tunnel on our R7. One is for R1, the other one for R8. Because we have two tunnel interfaces, and if we want, where is this? If we want to use single IPsec profile for both R1 and R8, we have to use this feature. We have to use sharing IPsec with tunnel protection feature. Without this feature, R7 will only establish neighborship with one tunnel, with one spoke, not with only with R1 or R7. Excuse me, R8. R7 cannot establish IPsec neighbors with both spokes without specifying this feature. And for enabling this feature on the tunnel interface, we add this shared command at the end of this command. Tunnel profile name, and we type shared. Okay, and for verification, we can use show crypto IPsec NPSA command. This is for verifying phase IPsec phase 1 or IPsec NP phase. This is QM ideal state. Yeah. If this is ideal, and we can use show crypto IPsec SA. I believe this command is for verifying IPsec phase 2, and we can use show crypto session command for checking our sessions. We can also use debug command, debug crypto IPsec NP. This is the display during phase 1, and debug crypto IPsec. This is phase 2 errors. And we can also clear our session by clear crypto IPsec NP. This is phase 1 security association, and clear crypto SA. This is clear phase 2 security association. Okay, that's it. This is the IPsec concept. And let's go and configure our section. We're using configure IPsec over DMVPN network using the following parameters. Use the following IPsec NP policy. This is our phase 1 policy. We have to the phase 1. We have to use pre-shared key. So our pre-shared key, DMVPN key. Encryption is AES, and hash is SHA-1, different group 5. This is the same parameter we have to specify on there this phase 1 command. Okay, let's configure. Open 7. This is hub. R1 is spoke. R8 is spoke either. Okay, this is one. All session. Check our DMVPN is working. Show DMVPN. This is spoke up. Now 7. We have 2 tunnel, and both are up and working. Okay, let's config IPsec config T. First, phase 1. Where is this command? What is our phase 1? This is keep the second policy command. Then we set the priority of protection suit. This is one number is specified. Then we have to specify parameter. One is pre-shared key. Okay, this pre-shared key is this key. Authentication is pre-shared, and this key is this one, this name. Crypto second key is, we have to specify, we have to conquer this key here. This key is for this number here. Crypto second MP key name. Okay, authentication is pre-shared. Authentication pre-shared. Encryption is AES 192 or hash SHA 256, and our development group, the group command is 5. And after this I have to exit and configure this pre-shared key with this command. Crypto IPsec key and key name is DMVPN. Key. And add this. Okay, because I have 2 tunnels, I will use wildcard pre-shared keys for simplicity. I just simply add this 0, 0, 0 and 0. This is wildcard pre-shared key. Okay, this is our phase 1. Phase 1 configuration is this command. Crypto IPsec MP policy, our parameters and our key and others. This is phase 1 or second configuration. Then I have to configure phase 2 IPsec profile. And this we have to use transport mode instead of tunnel mode. IPsec encapsulation ESP transport mode, encryption AES, and hash is this one. Okay, for conquering phase 2, I have to use this command. Crypto as a command transform set. Okay, it's not saying which name we should use. Let me check. Okay. I will use TS. Then I have to use ESP. Let me check. ESP. ESP AUS. ESP AUS. 256. And SHA 512. Very short authentication. ESP SHA 512. And mode, I have to specify mode, either tunnel or transport. We have to use transport mode here. Transport mode. Okay, this is IPsec phase 2 configuration. This is IPsec phase 2 configuration. Then it says when complete. When complete, R7 should form IPsec tunnel with the DMVPN spokes and ensure that a single IPsec profile is used on R7 for both tunnels. Okay, we have to use shared feature here, shared IPsec feature. First, I will not use this feature and let me see if what will happen. R7 will not form tunnel with both spokes. It will only with one spoke. Okay, let's use tunnel protection. This is tunnel protection with shade. We keep to a profile. First, you have to create crypto profile. Profile name. Let me see. There is no name. Okay. Crypto IPsec profile. I will call DMVPN and set transform set. This is our TS. I specified. This is our transform set. Now I have to go on the tunnel interface and upload this profile. Okay, let's copy paste this IKE Phases. Show down. This is after copy this config here and here. And on there exit to show IP interface brief interface tunnel. I use upload tunnel protection IPsec profile. My profile name is DMVPN. Exit interface tunnel protection profile DMVPN. Okay, now let's see this error. All tunnel interface having the same tunnel source and the same tunnel support must be configured with the shared keyboard. Okay, on there I will back. Exit. I will go to interface. Tunnel protection profile DMVPN and share. Then interface. Same command here. share. Let's go on export, exit, interface, okay, but first I have to, okay, to create that, okay. I don't have to share it on spokes, only on hub. Same here. Interface. Let's use this tunnel. And tunnel protection for DMVPN. Okay, now let's verify. I show commands on how. Let's first verify DMVPN is working. Show DMVPN up, and up. Let's ping up here. Ping. Working. It's working either. You have to ping with the DMVPN, ping VRF, DMVPN, DMVPN, oops, that's fast. Let's put tunnel IP address 192.17.1. This is this IP. This is DMVPN. Show IP interface brief. This IP, let's ping VRF VPN, which is working. Okay, let's see our IPsec. One is crypto IPsec PSA. This is we have QM idle and active. QM idle and our strategy is active, it is working. It means this our session is up and working. Let's see, show crypto SA 117. This is active and we are this session. The other one is show crypto session. Show crypto session. It says interface tunnel and it is session status is up and active. This is IKE phase 1. IKE number version 1. This is our crypto active. Oops. Let's wait for this session. Come on here. This is we have two tunnels, one up. Up and active. And last one, this command. Okay, the current user is this here. So DMV protector we have DMVPN, local address, so packet encapsulation. To the local crypto endpoint. Client outbound SPI and it is transport. We are using transport. Induce setting is transport and says active here, active for here. Also we are using transport and this is our transform encryptions, our parameters, our algorithm. You can see this algorithm here. Transform. Okay, that's it. I hope you have enjoyed this video and thank you for viewing.